So these Pythagoras theorem questions involve a bit more application, and they involve a bit more, or a few more steps that, as compared to some simple Pythagoras questions we've looked at earlier, where you just have a triangle and you have to find an unknown side. So over here, for example, this question here, we need to find the value of x. Okay, so if we look at x over here, we can see that we've got two right angle triangles, right? This whole image, it's basically made of two right angle triangles. Now to find x, if you remember our Pythagoras theorem, this is our hypotenuse. So to find x, we would not need to know the length of this side, which is 4 centimeters, and the length of this side, or BD, which we don't know. So the first thing you need to do is, if you want to find the value of x, you first need to find out what BD is. And to find out the value of BD, we use this triangle at the top here. We use this triangle ABD, okay? So if you look at the solution here, you can see I've written down here that we need to first find BD. And so we look at this triangle at the top here. So we just ignore the triangle at the bottom for this part. We just look at this triangle at the top. Now we know that BD squared is equal to AD squared minus AB squared. Now why are we doing minus? Because we already have the hypotenuse. We are finding the length of one of the shorter sides. So to do that, we have to rearrange the formula. Since we know that AB squared plus BD squared is equal to AD squared. Therefore, if you rearrange to find BD squared, it's going to equal to that. Now we know that the length of AD is 10, so you do 10 squared minus the length of AB is 5 centimeters, which is 5 squared. Okay, and that means that BD squared is equal to 75, and BD, or the length of this side, BD is going to be square root of 75. Now, we're not actually going to put that in our calculator yet because we don't want to make the mistake of rounding early on. Because if we use a rounded value in our calculations later on, then our actual answer is going to differ a little bit to what the real answer is. So just make sure in multi-step questions like this, we leave our intermediate answers in exact value to the variant. We only really round when we've got our final solution. Otherwise, our numbers could be a bit off, and that could result in a loss of marks in an exam. So now that we've got the length of BD, we can find the length of x, right? We know x is the hypotenuse. The x squared is going to be equal to this side squared, BD squared, plus CD squared. Okay, so BD is what we calculated, so that's root 75 squared, plus CD is already given to us as 4 centimeters. So we put that root 75 squared is just 75, and 4 squared is 16. So that gives us 91. And that means that x is equal to square root of 91. Now, since this is going to be our final answer, now we can round our answer. It hasn't specified in this case. So if it doesn't specify the number of decimal places, usually the best practice is to just leave it in its exact form. But I've just done it in 2 decimal places. Well, just to show you guys the 2 ways we can write the solution depending on what they ask. You know, if they ask for decimal places, they give them that many decimal places they ask us for. Usually, if they haven't given us any decimal places, it's either going to be a whole number answer, or if it's not, we just leave it in this exact form, in this square 91 form. Okay, we look at the next question. Now, this is a bit more difficult. This is something which you could get at the end of a question, you know, as a 4 or 5 marker, and you can see already from the wording of the question that it's an applied question, right? It's not a straight, just we're, you know, putting in the formula, crunching in some numbers. We have to apply that theorem to show a sort of an algebraic relationship, to show that c squared minus 2cx is equal to a squared minus b squared. Okay, now how do we sort of go about this question? So we know that, well, what was sort of done here is we know that we've got c minus x here, and we've got x here, okay? So what we're going to do is we're going to try and interpret or show these sides in terms of A, H, and B, right? Because you sort of have to get that idea, right? If you want to show that this is equal to this, we need to build a relationship from them, right? So we can see that c and c minus x has some sort of relationship with this side and this side using Pythagoras theorem, right? Similarly, we know that this side x has some sort of relationship with this side and this side, okay? And we're going to use our relationship to try and figure out if we can get this thing to be true, okay? So what I've done here is want to look at this part of the triangle first. If you look at the left-hand side, we know that over here, x squared plus h squared is equal to b squared, right? Again, just applying Pythagoras theorem, and we just know that x squared plus h squared is equal to this hypotenuse there. Just to show you guys, just so you're clear, I will just draw up the right angle here. You know that's a right angle, and therefore we know that this is the hypotenuse. Okay, so I'm just showing that there, just so you guys, that's clear. And then what I've also done is that means that x squared is equal to b squared minus h squared, right? So I've made x the subject of the equation. Okay, now I'm going to do the same thing for this triangle on the right here. Okay, so I'll just highlight that in a different color. Let's use green. Okay, so this triangle here, we're going to be doing the same thing. Okay, so I've done c minus x squared. We're in brackets, so we're looking at this. Side plus h squared, which is this side, is equal to the hypotenuse, which is a squared. Just to show you guys again, I know this diagram's getting a bit messy, but again, our hypotenuse is opposite the right angle. So a is our hypotenuse, as you've shown here. And then again, I've just making this side here the subject of the equation. So I've taken the h squared to the other side. So we have c minus x squared is equal to a squared minus h squared. Okay? Now, what I'm going to do is I'm going to expand this, right, using our difference of two squares. Sorry, not difference of two squares, using our a minus b squared, so our distributable property. So we've got c squared minus 2cx plus x squared is equal to a squared minus h squared. So now we can sort of see that this is kind of looking similar to what we have here. Okay, what are the extra things that we have, or what are the things that we are missing? So you can sort of work out what we need to do. So we've got an x squared here, right? And there's no x squared here. So we want to get rid of this x squared somehow. And then over here we have a b squared, but over here we have a h squared. So we want to get rid of those somehow. Okay, now how can we do that? Well, if you look at our first equation, we can see that we have an x squared here, and we have a b squared and a h squared here. So if we subtract these two equations, we can get rid of this x squared, we can get rid of this h squared, and we can also get this extra b squared that we want as well. Okay, so that's what I'm going to do. I'm going to subtract equation 2 from equation 1. So we've got c squared minus 2cx plus x squared. So that's the part of equation 2. And then I've got minus x squared. That's part of equation 1. Okay, I'm going to do a similar thing for the right hand side. So I've got a squared minus h squared. Again, that's part of equation 2. And then minus b squared minus h squared. And that's part of equation 1. Right? Now x squared minus x squared, that just cancels out. And then if I expand this bracket here, we get a squared minus h squared. Minus times b squared is minus b squared. Minus times minus h squared is plus h squared. Okay, so we've got the left-hand side exactly as we want it now. C squared minus 2cx. And we've also cancelled out this h squared like so. And we've got the right-hand side exactly as the same as well. And that's our solution. So that's how we have applied Pythagoras theorem to show that. So it is a bit of a tricky question. You know, sometimes it's to do with intuition a lot about what steps to do next. But you know, they've given you the hint that we do need to use Pythagoras theorem. So using that, you know, you look at, okay, I've got two right angle triangles here. They've given me the dotted line, so they want me to use this triangle and this right angle triangle. You know, well, what sort of equations can I make out of that, and how can I rearrange those equations so I can prove this? Okay, so yeah, try practicing this question again. You know, maybe put the rewind the video and try it again yourself. See if you can get there in a different way. And yeah, just practice with these sort of questions. Is really going to help you build that skill to solve these questions, because these will come in at the end of your exam. And these sort of questions are going to be worth a lot of marks. So you do want to be knowing how to answer these questions to maximize your marks there.